Welcome back, everyone. In this question, we want to find the exact values of the constant k, which the line y equals 2x plus 1 is a tangent to the curve y equals 4x squared plus kx plus k minus 2. These kinds of intersection problems are very common. We have a straight line intersecting a curve, and we want to know what values of k will make this line a tangent to the curve. Will we use the discriminant to solve these kinds of problems? So here we have the discriminant listed. Now, this is your discriminant. When your discriminant is negative, there will be no points of intersection. When your discriminant is equal to 0, there will be one point of intersection or a point of tangency. When your discriminant is positive, there will be 2 points of intersection. So for our particular problem, we want to know what is k such that the line will be tangent to the curve. So for our particular question, it mentions tangent. So we're interested in the second equation. So the first step in solving these problems is to combine your equations. So we've got y equals 2x plus 1 and y equals 4x squared plus kx plus k minus 2. So we can join them by making them equal. We have 4x squared plus kx plus k minus 2. So now let's rearrange this to be a quadratic equation. We'll have 4x squared plus kx minus 2x plus k minus 2 minus 1 equals 0. So in the next line, we'll write 4x squared, and these two terms will combine, and I'll write a minus 2 in brackets and put x on the outside. So essentially I've factorized out the x. And this is k minus 3 equals 0. So we can compare that to our quadratic equation, which is ax squared plus bx plus c equals 0. So we can see that a would be equal to 4, b is equal to k minus 2, and c is equal to k minus 3. So now we'll write down the discriminant that we use, which is b squared minus 4ac equals 0. And we substitute the values of a, b, and c into that equation. So we have b squared, and b is k minus 2. So we have k minus 2 all squared minus 4 times a, which is 4, times c, which is k minus 3, equals 0. So now we need to expand and simplify the equation, and then we solve it for k. So we have k squared minus 4k plus 4 minus 16 times k minus 3 equals 0. So let's expand some more. We'll have k squared minus 4k plus 4 minus 16k plus 48 equals 0. This will reduce down to k squared minus 20k plus 52 equals 0. Notice that the question mentions exact value. This is suggesting to me that we can't factorize this problem. And if you try to factorize it, you won't be able to. But we'll use the quadratic formula to solve it. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In this case, a will be x. So let's substitute our numbers to the formula. We'll have k equals negative b, and b is already negative 20, so we can write 20 plus or minus the square root of negative 20 squared, which is 400, minus 4 times 1 times 52. All divided by 2a, and a is 1, so that's 2. So this reduces to 20 plus or minus root 400 minus 208 divided by 2. That will be equal to 20 plus or minus root 192 on 2, which can be written as 20 plus or minus 8 root 3 divided by 2. And we can cancel here. So that will give us k equals 10 plus or minus 4 root 3. And this is your final answer. Thanks for watching.